Baiklah, karena acara akan segera kita mulai, buat teman-teman yang masih belum on kamera, bisa on cam dulu. Oke, baiklah. Yang belum on kamera, segera on kamera ya, karena acara akan segera kita mulai. Oke, baiklah, langsung kita mulai saja. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Baiklah, sebelumnya saya akan menyapa rekan saya terlebih dahulu. Selamat pagi, Jordan.
Good morning to you too.
Oke. Selamat pagi kami ucapkan kepada Kepala SMK Telkom Purwokerto, Bapak Wibit Widiantoro beserta jajarannya, Bapak Ibu Guru Wali kelas 10, 11, dan 12, dan rekan-rekan panitia serta teman-teman kelas 10, 11, dan 12, serta teman-teman yang menyaksikan via Zoom maupun live di YouTube.
Let's make this morning livelier. Everyone, let's open today's event with our usual spirit chant. Semangat pagi. Pagi. Thank you everyone.
Oke, baiklah, langsung saja untuk mempersingkat waktu, akan kita mulai bersama acara Living and Playing pada hari ini. Saya Rifki Hidayat dan rekan saya Jordan, izin untuk membuka acara.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning and greetings to all of you. Utmost respect to our principal of SMK Telkom Purwokerto, Mr. Wiwit Widiantoro, as well as the teachers, staff, and the management team. Greetings to the audience that are watching this through Zoom and YouTube too.
Baiklah. Puji syukur senantiasa kita panjatkan kepada Allah Subhanahu wa taala, Tuhan yang Maha Esa, atas berkah dan karunia-Nya sehingga pada hari ini kita masih dapat mengikuti rangkaian kegiatan dengan keadaan sehat walafiat. Sholawat serta salam tak lupa kita haturkan kepada Nabi Agung Muhammad Sallallahu Alaihi Wasallam yang kita nantikan syafaatnya di hari akhir kelak.
Before we begin today's living and playing, allow us to read out today's series of events. First off, we will sing our school's anthem, Jayalah Telkom and Mars Telkom School. Second is the main event, the Blockchain Technology Workshop by Help University of Malaysia. And lastly is the closing.
Baik, terima kasih Jordan. Untuk mengawali rangkaian acara kita pada hari ini, marilah kita membaca basmalah bersama bagi yang muslim dan menyesuaikan bagi yang lain. Bismillahirrahmanirrahim. Baik, terima kasih semua. Semoga dengan membaca basmalah dan doa bersama akan dapat memberikan kelancaran dan bermanfaat pada kegiatan kita hari ini. Amin. Memasuki acara kita yang pertama, yaitu menyanyikan lagu Jayalah Telkom dan Mars Telkom School.
Mewujudkan segala impian. pendidikan anak Indonesia, calon untuk pemimpin bangsa. Satukan tekad jiwa yang kuat, bangun harkat citra negara. Telkomsel mengembangkan generasi muda dengan kompetensi yang nyata. Prestasi pendidikan yang berkesinambungan untuk jadi unggulan anak negeri. Maju-majulah Telkomsel Indonesia, membangun karakter siswa. Jaya-jayalah Telkomsel Indonesia, siap cerdas dan tunas muda bangsa. Pendidikan anak Indonesia, calon untuk pemimpin bangsa. Satukan tekad jiwa yang kuat, bangun harkat citra negara. Telkomsel mengembangkan generasi muda dengan kompetensi yang nyata. Prestasi pendidikan yang berkesinambungan untuk jadi unggulan anak negeri. Maju-majulah Telkomsel Indonesia, membangun karakter siswa. Jaya-jayalah Telkomsel Indonesia, siap cerdas dan tunas muda bangsa.
Okay, moving on to the main event, which is the Blockchain Technology Workshop from Help University of Malaysia.
Oke, baiklah. Tetapi sebelum menuju ke acara berikutnya, kita juga kedatangan moderator di sini ya. Halo, selamat pagi Bapak Bobi Bestari.
Ya, halo, selamat pagi, Mas Rizky, Mas Jordan, Kepala Sekolah SMK Telkom, dan adik-adik semuanya. Saya Bobi dari Hub University Malaysia. Sebentar lagi kita akan akan ada dosen dari Departemen IT dari Hub University yang akan present tentang Blockchain Technology Workshop. Oke, sebentar ya. Ya, sebentar lagi beliau akan join. Jadi sedikit tentang Hub University. Hub University adalah universitas swasta yang berlokasi di Kuala Lumpur di Malaysia. Dan kita saat ini memiliki program IT yang cukup yang mana subjek yang kita bertawarkan ke siswa itu sangat relevan dengan apa yang dibutuhkan oleh industri di saat ini. Dan hal yang paling hype akhir-akhir ini tentunya adalah kripto teknologi, kriptografi, dan mungkin beberapa dari kita juga notice dengan berkembangnya teknologi, salah satunya yaitu Bitcoin, dan di mana-mana orang-orang ngomongin Bitcoin lagi naik, lagi turun gitu loh. Nah, terus tentunya Bitcoin ini nantinya akan sangat relevan dengan apa yang adik-adik hadapi ketika terjun nantinya di dunia kerja mungkin 4 atau 5 tahun lagi gitu.
That's very interesting, Mr. Bobby. But may I ask a question?
Yes.
I'm wondering, how is Help University found? How is it found? Like, is there a story behind it?
Ya, Help University itu didirikan dulu sejak tahun 1986, jadi kurang lebih sudah 35 tahun yang lalu. Dan itu didirikan oleh beberapa founder kita, yaitu Dr. Paul Chan bersama beberapa rekannya di Kuala Lumpur, Malaysia. Dan tujuan dari didirikannya Help University ini adalah membantu meraih siswa-siswa yang tadinya mungkin punya keterbatasan untuk mengakses pendidikan agar memiliki pendidikan yang setara dengan siswa-siswa lainnya di Kuala Lumpur di Malaysia gitu. Dan semuanya berjalan sukses hingga sekarang, hingga Help University memiliki sangat banyak sekali partner university di seluruh dunia, sehingga siswa bisa memilih antara misalnya selesai kuliah 3 tahun di Malaysia di Help University, atau misalnya menyelesaikan di universitas rekanan kita, misalnya di Australia, di UK, dan banyak negara lain di seluruh dunia gitu. Dan khusus untuk jurusan IT sendiri, mungkin yang bikin berbeda dengan jurusan lain di universitas lain di Malaysia, di Help University kita punya jurusan IT yang memungkinkan siswa untuk magang selama 1 tahun penuh. Artinya siswa akan kuliah selama 2 tahun di kampus di Help University, lalu 1 tahun ketiganya itu akan kuliahnya tuh berpindah ke perusahaan. Jadi mereka magang 1 tahun dan dihitung kuliah di sana. Dan ini sangat bagus karena siswa akan punya pengalaman yang lebih banyak, dan peluangnya untuk direkrut di perusahaan tersebut itu semakin besar. Dan not mention siswa pun mendapat allowance yang sangat besar dari perusahaan, karena perusahaan melihat komitmen yang lebih besar dari siswa ini ketimbang siswa-siswa lainnya. Karena pada umumnya di Malaysia itu magang itu cuma 1 semester, yaitu 4 bulan saja. Nah, sementara dengan adanya kerjasama yang erat antara Help University dengan advisory board dari perusahaan-perusahaan ini, itu memungkinkan siswa-siswa Help University yang jurusan IT itu untuk magang lebih lama ketimbang siswa-siswa lainnya gitu.
Baik, sangat menarik sekali ya untuk sekilas tentang Help University. Tapi saya ada pertanyaan lagi, Mister.
Yes.
Kira-kira boleh nggak ya bertanya?
Iya, boleh, silakan.
Oke, baiklah. Dengan 1 tahun kuliah dan 1 tahun magang tadi, tentunya kan sudah banyak pengalaman yang didapat oleh siswa-siswi ini, Mbak.
Ya.
Kira-kira ada nggak semacam karya atau sesuatu yang sudah dibuat sama siswa-siswi dari Help University?
Ya, mungkin nanti bisa lebih detail juga ke dosennya, karena Mr. Qayyumnya sekarang sudah join. Mungkin nanti bisa Pak Jordan atau Pak Rifki bisa minta tolong dijadikan co-host untuk nanti beliau bisa presentasi, Mr. Qayyumnya. Ya, dan satu hal terkait dengan prestasi yang sudah pernah dibuat oleh siswa-siswa, terlebih dari siswa dari Indonesia. Itu kita beberapa tahun yang lalu ada salah satu siswa dari Indonesia yang akhirnya mendapat mentoring langsung dari Google karena mereka bikin aplikasi Jarvis. Dan itu dimentoring oleh Google sendiri dari Silicon Valley. Dan itu mendapat penghargaan dan masuk ke media waktu itu. Dan itu siswa dari Indonesia. Dan mungkin saya bisa langsung perkenalkan ya, Pak Jordan ya, Pak Rifki ya. Ini dosen kita ini saat ini akan memberikan presentasi terkait dengan blockchain teknologi. Ini nggak akan detail tentang apa itu blockchain, tapi lebih pengenalan saja dulu, pengenalan dan sedikit praktek. Jadi buat siswa-siswa yang saat ini online dengan laptop, barangkali mungkin akan lebih membantu karena bisa lebih multitasking untuk hands-on ke praktek dari blockchain teknologinya ya. Jadi Mr. Dr. Abdul Qayyum Hamal ini adalah dosen yang mengajar di IT, di Departemen IT di Help University, dan sudah mengajar selama 5 tahun lebih, dan punya pengalaman juga 7 tahun lebih di engineering and IT industry sebagai senior software engineer. Dan beliau punya skill komputernya itu di Unix, Linux, Windows, C++, Java, PHP, JavaScript, MATLAB, machine learning, Python, dan lain-lain. Dan beliau juga menyelesaikan PhD-nya Computer Science di International Islamic University Malaysia. Dan biar biar kita nggak terlalu buang-buang waktu, mungkin adik-adik udah pengen tahu langsung apa itu blockchain teknologi. Oh ya, satu hal lagi mungkin saya perlu sampaikan buat adik-adik, kalau misalnya nanti ada pertanyaan, bisa langsung bertanya saja, karena ini mumpung dosen dari IT Departemen, dosen dari universitasnya yang ngajar kalian untuk 1 jam ke depan, jadi langsung bertanya aja, karena kesempatan seperti ini kan nggak akan ada tiap hari. Atau mungkin nanti kalau malu bertanya, raising hands, atau mungkin bisa di chat di kolom chatting di sini kali ya, seperti itu. Oke, saya kira kita langsung alihkan ke Mr. Koyum. Is it good?
Sure. Go ahead.
Mr. Abdul, are you around? You can start now. Hello, Mr. Abdul.
Hello, good morning. Okay, hi.
Morning.
Hello, everyone. Hello, my younger friends from Indonesia.
Hello, Mr. Kayum. Good morning.
Nice to see
Hello,
you.
good morning. Nice to meet you.
Okay, let me just allow me to share my slides here. Okay.
Yeah, yes, please carry on.
Can you allow me to present? Actually, I want to share the slides here. Okay, I'll share the screen. Fine. Is it up there? Is the screen visible there?
Yes.
Yes, we can see it.
Yeah.
Okay then. Okay, again, good morning, everyone. My name is Abdul Qayyum. Just a very, I think I have already been introduced, but still I'll just introduce myself. My name is Abdul Qayyum. I'm a faculty member in the Faculty of Computing and Digital Technology in the Help University Malaysia. Okay. So I think that's my introduction. So today we'll be having a sharing session rather, okay, on blockchain technology. Okay, the fundamentals of the blockchain technology, we'll go through it today in the next around 40 minutes or so. So this is our outline for today. So first we try to get the overview of the blockchain and especially why blockchain, okay? Then we move on to the structure of the blockchain, what's the infrastructure, how it is built, okay, what are the different components of blockchain technology, okay, and then what are its various types, we'll touch upon that briefly. And then important is what are the different, how it operates, of course, the blockchain, so we'll be talking about smart contracts, and we'll be talking about the ledgers and etc. Fine. Then we'll see the use cases of the blockchain, where the blockchain is being utilized and what are the potential uses of blockchain. And finally, we'll discuss about something called as Bitcoin, okay? So now, just simply to make the session quite engaging, let me ask here, how many of you have heard about blockchain before? Maybe probably a show of hands here. That can give me some idea.
It seems pretty new for everyone here.
So I can see none of the hands going up. Is it or? Anyone here having heard about the term blockchain again? You can simply turn on your mic, or you can simply have a show of hands. So I think I don't think anyone here, has. Okay,
We
some
can hear you. It seems that it's pretty new for everyone here.
Okay, but how many of you have heard about Bitcoin? Let me now ask about Bitcoin.
Ya, adik-adik ada yang sudah pernah tahu soal Bitcoin atau blockchain? Mungkin bisa angkat tangan.
How many of you heard about Bitcoin? It's a buzzword actually, especially these days.
Yeah.
And many youngsters are actually involved. A lot of people involved in the Bitcoin. Okay, so quite a few hands over there, right? Fine. Okay, good.
Maybe
Okay.
it's electronic currency.
It's an electronic currency. Right. Okay. Okay, good. Fine. Okay. Thank you, everyone. So now, because why I asked this question is mostly I have seen that people have this, or it's kind of synonymously being used. Okay, or sometimes people get confused with blockchain and Bitcoin. Okay, they think it's the same, but then blockchain is not Bitcoin. Okay, blockchain is not Bitcoin, but then we'll see what is the relationship between blockchain and Bitcoin as we move forward in this session. Fine. So what is blockchain? Now, in order to understand the blockchain, first we need to understand its what are the factors actually that everything. If you see any invention, any discovery, okay, it has some background. Okay, why it came into being. You talk about anything. I suppose many of you here are like you are tech savvy people, IT people. Like if you do it like simple, we talk about programming, right? We have different programming languages, right? So we have, for example, C, C++, Java, right? Python. So these are the different programming languages. But then each of these programming languages, they have a history. They have some background why they came into being. Okay, what was the requirement? Fine. Similarly here for the blockchain, okay, there is something we need to understand that there is some underlying, there are some underlying reasons, okay, why we need blockchain. Finally, simply actually, let me put it in the simple terms. One term I'll use is trust-based transactions, okay. In our daily lives, we perform different types of transactions, whether it's monetary, right? We transfer money, or you talk about trade, you talk about any business transaction, okay? What is of the vital importance, what is critical is the trust factor, okay? Now, what blockchain provides, it's a peer-to-peer network, okay? It's a peer-to-peer network, fine? Or in other words, we say it's a distributed ledger, okay? We'll again go through these terms later. Now, if you just give you a, like if you see the compare using you compare it using a traditional ledger. In the traditional ledger, what do? For example, you go to any business entity, okay? What used to happen is, okay, they record everything, any sales, any purchase of any commodities, sale of commodities, anything. So they would write in a ledger it's time stamped. That's the important thing. So date wise, and then it's time stamped. It's following certain order, which is based on time. Okay. Now you compare it. That's a traditional thing. That's traditional ledger. Okay, that you can see here, an example. Now the blockchain, it's peer-to-peer network. So it makes use of different, what we call these nodes. Okay, these you can simply say, for example, here, these are nodes, some computers. Okay, so blockchain is a peer-to-peer network that timestamps transactions. So that's important. It timestamps transactions, okay, as a way to eliminate third-party services. Okay, now again that trust factor, I'm again coming to that trust factor. Now, for example, any transactions, for example, okay, I'm opening my, for example, my banking application here. So I want to transfer some funds to my friend. Okay, so now there are a lot of entities involved. Okay, especially for example, when you talk about banking or online banking, okay, there is something like a central bank. Okay, every country has a central bank which is regulating these things. Like in Malaysia, we have Bank Negara. Not exactly sure in something similar in Indonesia as well. Or for example, if you see in the US, you have the Bank of America, or likewise in other countries. So these are the regulatory bodies. Okay, so they oversee all of these things. They govern the governance and other things. They define how these things will happen. So there are, in nutshell, there are intermediaries involved. Okay, it doesn't happen peer to peer. You understand? For example, now I was about to send some funds to my friend. It's not that it's only between me and my friend. No, there are many other entities involved in between. But then what blockchain provides is, anyway, what these intermediaries ensure is, okay, we have some trust. Okay, I have trust. Okay, if I'm, for example, transferring 100,000 ringgit. Okay, actually, I expect 100,000 ringgit from someone else. Fine. So the thing is, in the transaction, there's a trust. Okay, there is the entities involved. They are trustworthy. Okay. Now here, this eliminates the third-party services. But because one more thing is, when you have these intermediaries involved, there is cost also involved. Okay, they have their commission, they have their fee. Okay, fine. But then what blockchain provides, it takes out that intermediary out, and it provides you a mechanism now. So again, that trust thing. Okay, we'll see there are different ways. You have different contracts, consensus, and other things through which it provides that trust. Fine. Now, what are the current characteristics of blockchain network? Distributed ledger. Okay, ledger, we know you record every transaction and its timestamp. Fine. And then this, here we have this peer-to-peer. Okay, and then it's distributed. Now you see here, it's not centralized. The ledger means that the record is available on each and every node, and they have exactly the same copy. That's one thing. It's distributed, right? And then this is something which is decentralized. The whole system is decentralized. Okay, the record keeping is all decentralized. You compare it with the centralized system. Okay, wherein you have a centralized system, all your things are only at one place. Okay, but here these are distributed, and then this particular ledger is shareable. It's shared across all the different nodes, actually the entities. Okay, for example, if we talk about let's say the same, the funds transfer. So it involves sender, receiver, and other things. So it involves all these entities involved. They have this shared ledger available with them, which is verifiable. Okay, and then so it's decentralized. Okay, consensus. Okay, so now the factor is, how does the blockchain provide the trust? Okay, trust in terms of when you are going to do any kind of transaction, how it actually provides that trust. So there is something called as consensus or trust-based transactions. And then immutable. Immutable is very important characteristic, in the sense immutable means it cannot be changed. Once it's written, it's written. Okay. So it cannot be changed at all. That's why the name immutable, tamper-proof. Okay. So, okay, fine. So it's immutable. You cannot change the contents of this transaction so what will happen actually, because how it is making sure that it's immutable, because now this particular copy is available with every node here. Okay, so if any change is detected, that particular transaction will be discarded. Okay, so it has to be immutable. Now again, if you see these important things here, regarding the blockchain. Okay, so one is decentralization. Okay, Then there is disintermediation. The intermediates are taken out. Okay, and then distributed immutable ledger. Okay, so it's a ledger, it's immutable, and it's shared across all the nodes, so it's distributed. Okay, so blockchain is a technology that provides the hardware and software. Now to realize all these things, okay, it needs a vast infrastructure, okay, like it needs hardware support, it needs software support. Fine, so the blockchain is the thing which provides all these things: hardware, software, and on top of that, it provides the access, it provides the what you say, the security in terms of protocols. Okay, it allows you to define protocols. Fine, so that's what blockchain is, a trust layer on the internet. Now it's built on top of internet. Now if you look at, for example, we talk about information, right? We live in an information age, information age, right? And then the biggest enabler of this is the internet, what we have today, the internet. Okay, so you share information, so again, when you share the information across internet, what are you worried about? The thing is, the important thing is the data integrity is important, right? And what are the other important things? Like, for example, you don't want to be a victim of cyber attacks, or you don't want your information should get leaked. So many other things lead to the information. Okay. Similarly, in case of the blockchain, we have these, as I said, that it adds that trust layer. So when you talk about internet, it's related to it provides you that information ecosystem for the information exchange. Similarly, blockchain, it's again on top of the internet, it provides you the ecosystem for transactions. Okay, it provides you the infrastructure for transactions. Again, transactions can be of any sort. Okay, you are making, for example, banking transactions, you are buying some property, you are in some even the education sector. Okay, different type of transactions can happen. So we'll talk about it. Fine. So on a strong foundation of more than 40 years. So it's not that, of course, it may appear as a new thing. Okay, blockchain, but then it has strong foundations in the computer science. Okay, it has science of cryptography. Okay, it's not that. Now again, when you say that transactions happen, so there has to be some information exchange. So that information is protected, secured. How? It employs something called as cryptography. Simply, cryptography, the information which is exchanged between the different entities, okay, it's encrypted. Okay, encrypted means it's not readable. And how it is read is there is a mechanism called it has something called as keys, public key, private key. Okay, that kind of mechanism is employed. So that's the science of cryptography. And then again, hashing. Okay, then the network protocols, you have the peer-to-peer. Okay, then for the contracts, you have the consensus protocols. Okay, so these all are these are the concepts from the computer science, and this blockchain technology makes use of these foundations. Okay, now it's used. So what it helps us is it enables automation, accountability, okay, efficiency, accuracy. So we'll see, and ease of use, fairness. So we'll see these things here. So let's move forward. Okay. Now what you see here in this diagram is, again, you see here, the bottom layer is the internet. So you understand from here, in order for the Bitcoin, sorry, not the Bitcoin. Okay, I also got confused here between these Bitcoin and the blockchain. So blockchain, it needs internet in first place. Okay, so that's the basic layer, this one here, internet. Now, in our daily lives, we are using internet quite a lot. Okay, how? You see the World Wide Web. You just open your browser, you want to search for some information, you want to do some transaction, you want to you open anything, okay? You want to go for social networking, so you use your browser in your mobile or on your desktop or laptops. So this is the World Wide Web. It enables you to exchange the information. Now, you can do any kind of things, okay? You want to watch a movie, entertainment, you want to do some kind of transaction, you want to buy something, for example, from Lazada, or for example, from say any other say the other website, then information exchange, right? But then what happens is this www, the World Wide Web, so it has protocols. It defines its protocols, how the information has to be exchanged, right? So those protocols, like we talk about, the one of the important protocols is HTTP, Hypertext Transfer Protocol. It uses other protocols also. For example, you are sharing files, that uses a protocol called FTP. If you see here, yeah. So we have HTTP, Hypertext Transfer Protocol, and then there is HTTPS. You want to make it more secure, and you see most of these banking nowadays, all the other applications, they will use the protocol HTTPS, Hypertext Transfer Protocol, secured. Okay, it adds a layer of security there. Fine. Then you have FTP. You want to share files, so behind that there is a protocol FTP, and then again for the mails we have SMTP. Okay, simple mail transfer protocol. We have Telnet. So many other protocols. So this is all defined in this. So you have the World Wide Web. Okay. Now on the other side of it, now you see the internet. Built on internet is a technology that's blockchain. So it again uses the internet. Okay. Now what it provides, as we have seen earlier, peer-to-peer. They have mechanism to allow transactions, and it adds a layer of trust through different means. So it actually, it's a decentralized peer-to-peer network. Okay. Now here you see you have, similarly here you have things like consensus algorithms. You have distributed ledger. Okay. Through these mechanisms, it has its own protocols. Okay. Smart contracts. Fine. Now if you see I asked earlier about if you have heard about blockchain, okay, because most of people now, in the many people are in this Bitcoin related things. Now, if you see the Bitcoin, it started around 2008. Blockchain was already there much earlier than the Bitcoin. But then what Bitcoin provided is it brought the blockchain into the limelight. Okay, we can say simply a use case of blockchain. Okay, Bitcoin simply used blockchain technology. Okay, it started again, it started in around 2008 and 2009. Again, that time, if you see, it was the time when there was economic recession. Okay, the Lehman Brothers had bankrupted, they went bankrupt, and there was economic meltdown all over the world. Fine. So that time it was the inception of the Bitcoin. Again, what is that? Simple. It's a cryptocurrency. It's a digital currency. Okay, encrypted currency. Fine. But now, if you see, it's not only limited to the cryptocurrencies. Okay, you have many others now. Okay, apart from Bitcoin, but then Bitcoin is the most popular, most widely used. Fine, among the cryptocurrencies. Now it's not only limited to the Bitcoin. Now, if you see, the blockchain finds the applications in other areas as well. Like you see in healthcare. Okay, you have the patient record system, you have the billing system, you have the insurance, and etc. and etc. You name it. Okay, and many countries are actually implementing. Okay, there are some countries in Europe, Eastern Europe, I think Estonia and others, fully implemented the blockchain in their healthcare systems. Okay, at the government level. So then there are autonomous decentralized applications as well. And now you see it finds the applications in different areas. Now here,
I'm very sorry, Mr. Koyung.
Yes.
I'm very sorry to cut you off, but may I ask you to speak slower? I don't think the students here can follow your explanation. I think it's too fast.
It's too fast. Okay, thank you. I'll be a little slow.
Okay, thank you very much.
Okay, fine. Fine. Okay, so what we are talking about is blockchain, some of the applications of blockchain. Okay, now, again, as you see here, what it provides computing infrastructure. Okay, it allows you to write some, simply I'll say the coding. Okay, you can code it, you can program it. Okay, and that we call here smart contracts. Okay, it provides a mechanism of validation, verification. Now, for example, in a transaction, there's a sender, there's a receiver. So you need to verify, you need to validate the credentials of both the parties. So here, the blockchain provides that mechanism. Okay, and again, I talked about earlier, the immutable ledger. Fine. Someone's mic is on, please turn it off. Okay, so if you see the whole system, the whole blockchain infrastructure, this one on your left side is a traditional centralized system. Talk about banking. Okay, so the transactions that, for example, as a customer, okay, so you can do different transactions, and as I mentioned earlier, there are regulatory bodies involved. Okay, I gave the example of Malaysia, like you have Bank Negara and other things. And one thing with the centralized systems is, again, if you see that if you understand the nature of the transactions, banking or other transactions, they are delayed, or credit cards. Okay, the receivers actually won't get the payment. Okay, there's a time gap, actually some 15 days. Until that time, they won't get that. All the transactions actually, or the amount is in some kind of intermediary state. Okay, which can be rolled back. Okay, they don't get it instantly. And so there are many other things, issues involved in the traditional systems. Now,
sorry, Mr. Abdul Qayyum, can you speak slowly, because some students are trying to listening to you here. A bit slowly, I mean.
Is it still fast? Okay, then. Okay, I'll slow down a bit more. I'm worried about the time also there. It's already 11. Anyway, so now, traditional systems, this is the traditional centralized system, example of a banking system. Now, what blockchain provides is a decentralized system. You see here, different entities involved, they are connected to each other. That's what I earlier said, peer-to-peer network. It's peer-to-peer network. Okay, so functions of intermediaries are shifted to peer-to-peer peer participants and blockchain nodes. So here you don't have any financial institution or some regulatory body, nothing of that sorts in blockchain. Okay, only the stakeholders, the entities are involved. Okay, so this intermediation, so you have the validation, recording, verification using blockchain software. That's all provided by the blockchain ecosystem. Fine. Okay, now let me give you one more example here. Now, for example, tomorrow, for example, you want to apply for your higher studies in some different countries, for example, US, okay, Europe. Now, say some top universities. Now, what it requires you to do is you need to get your documents, attested, cleared, right? For example, you have done your, for example, graduation. You have done your bachelor's in computer science. Now you want to apply for master's in some university, for example, Oxford University, for example. Okay. Now the requirement is, okay, your documents, you have to get them attested, whether they are true documents or not. Now, for now, see how the process happens is you will send them the documents. Okay. Then they have a mechanism of independently, verifying your documents means they will be contacting your institution, and again they will check there if the documents you sent there, if they verify it there, okay, in that manner. But then if you see, if such kind of system is available in a decentralized manner, okay, you as a student want to apply, okay, the universities, say some universities here, some organization, they already are connected in this decentralized system. They already have the information about your, for example, your past degrees, say your degree in computer science or other things. So they can already easily fetch the details, okay, and they'll be sure that this is not something which has been forged document. This is not something which has been changed, okay, or which has been tampered, okay, because that blockchain provides that mechanism, right? So that it will be easy. But then if you see in the centralized system that is currently available, it has the limitations, okay, you have to wait for it, the verification to happen and other things involved. Right? This is one example. Fine. Now let's see what blockchain consists of. What are the different parts of blockchain? Okay, is my this voice audible and the pace is okay now? A bit slow down, right?
Yes, sir.
Okay, fine then. So it has three parts. One is, from the name itself, you can see block, chain, and network. As you can see here, you have blocks, okay, as you can see in the diagram, okay, and you have some kind of link, what we say the chain, these are the links, and then this forms your whole, we'll see this blockchain network. And this important thing here is some kind of, security mechanism, okay, that is where we have this cryptography and hashing involved, okay, which ensures that the transactions are secured. Fine. Now, what is a block? A list of recorded transactions over a period of time. Again, the transactions are time stamped, very important, okay? A list of recorded transactions over a period of time. Transactions can represent virtually any type of activity. Now you see, yeah, you purchase a property, some land, some property, again, so that's all recorded in the, what we say, a block. It has its own fields, different fields in the blockchain. A block has different fields. We'll see some example of a block. What are the different fields in the blockchain block? Okay. Then chain. When the block reaches its maximum size of transactions, it is linked or chained to the preceding block through a hash. Now, it's a dynamic thing, right? There is a size limitation on each block. Now, if it reaches that maximum size, what happens? You have to move to the, it's like, for example, you are writing some assignment. You are writing from in a document some assignment, page 1 you finished, now you move to page 2, page 3. Similarly here, one block is finished, now you have to move to the next block. Now, what is the connection between the preceding transaction, that is block 1, and now the succeeding transaction, which will be in the block 2, okay? That kind of link together, that chaining, that's the chain, and then that happens through something called as hash. It's a, simply you can say it's a computer generated code. We'll see this one, okay? It's called a hash, a link. What's hash? Now again, as we said earlier, the fundamentals of the blockchain, they are, this is actually, the blockchain is built on the concepts of the computer science. Okay, so here we are using algorithms. So hash is an algorithm that takes a variable string of data and generates a fixed length value, as you can see here. For example, now each entity will be having, for example, its name. Okay, but then when its hash value is generated, it's not something which is readable. Okay, this also ensures security mechanism. The data about transaction must be small so that the validity of transaction can be quickly calculated and distributed. So the thing is, related to each of these, it generates a hash value. Okay, fine. If it's longer, then of course the hash will be longer. Okay, it takes time to calculate. So earlier I was talking about a block. So this is an example of block, specifically about Bitcoin. Okay, because Bitcoin is an application of blockchain. Bitcoin uses blockchain. Fine. And for that Bitcoin, this is the structure of the block, how it looks like. So you can see at the top here, there is hash. Okay. So now when the blocks are connected to each other, okay, they have this hash. It has the address of the previous. It has the hash address or address in the form of hash of the previous block. That's how they are interconnected. Okay, then you see each of these has a timestamp. Okay, then it has many other fields. Okay, what's the size and other things. Okay, transaction volume, but this is related to the Bitcoin. And if you see other applications can have their own type of headers or the contents, but then what is important is this hash. Okay, the link. Fine. So now if you see so you have the block, you have the chain, okay, which is actually provided by the algorithm, hashing algorithm, okay, and then the structure, how the blockchain structure is developed, that is a combination or a collection of all such nodes, we call them. So this is a node or a header. Okay. So blockchain technology, each page in a ledger of transaction forms a block. Okay. I gave the example earlier, like you do assignments, you had consists of many pages. Okay. Similarly here, a transaction here. So here it spans across different blocks. Okay. That block has an impact on the next block or page through cryptographic hashing. So this is cryptographic hashing. In other words, when a block is completed, it creates a unique, and this is secure code, which ties to the next page or block. So these all are secure links. These cannot be tampered with. Okay, these cannot be tampered. Why this is important now? For example, in some blockchain structure, like you have the hackers and others. If, for example, they want to overwrite or they want to modify this block somehow or replace this one, if they somehow know the hash here, they can simply replace it. But then it's not possible. Why? Because this is the link here itself is encrypted. It's using cryptography. Okay, it's secure. Fine. Now there are, if you look at the network itself, okay, the network is made up of nodes that each contain a complete record of all transactions on a blockchain. Okay, no centralized, so this is distributed. This is the structure. I'll quickly move here. So this is the distributed network, which is actually in the blockchain. There is no centralized thing. Okay, and each node has that shared ledger available with them. Okay, shared distributable ledger. Now, if you see the whole blockchain ecosystem, it's a system that comprises of many things, but some of the important things that need to be mentioned here are these: transactions, immutable ledgers. Okay, some of these we touched upon earlier: decentralized peers, encryption process, consensus mechanism, and optional. You can the blockchains can have their own kind of these contracts, what we call the smart contracts. Okay. Now, what are the transactions? As with enterprise transactions today, blockchain is a historical archive of decisions and actions taken. So anything, if you see any kind of transaction, decision making or any other thing, so it records every bit of it. Okay, proof of history, it provides provenance. So this all can be tracked. Okay, this is all time stamped. Fine. Again, important thing is the immutability. Okay, that will come later. If you see the different what do we say, the use cases. Okay, land registration. Okay, replacing requirements for research of deed. Okay, so it's already implemented and being actually used is in Sweden land registration. Similarly, as I talked about earlier, in Eastern European countries like Estonia, they are using blockchain for healthcare, in personal identification. Okay, So these are some of the use cases. Okay, transportation. Okay, so here again, you see in the transportation, like you see in the shipping industry also, especially because this Mersek is in the shipping industry. So you have, every day you have these the huge amount of goods are transported through the maritime, right, the sea, right, different containers. Again, how it keeps track of this is through the blockchain. Okay, then of course the banking. Okay, banking has still issues because I'll talk about it at the end of it, that there are certain still limitations to this, okay, in terms of and enforced by the regulatory bodies. Okay, then manufacturing, food distribution, so many other applications are there. Okay, so now the thing here is, when we talk about transaction, it's not a financial transaction only. Okay, it can be any type of transaction. Fine. Immutable. So another characteristic, immutable. As with existing databases, blockchain retains data via transactions. Okay, like you have the different databases we talk about, for example, Oracle, Oracle databases, right? Oracle 12i or Data Cloud, Oracle 12 Cloud, or you have IBM's database, DB2, you have MySQL, I have Microsoft's MySQL server, okay, SQL server. So different centralized databases. Similarly, blockchains, what they have, they store. So if you try to differentiate, these databases store the data, but then here, this retains the transaction-related data, the blockchain. That's important. Okay. The difference is that once written to chain, the blocks can be changed, but is extremely difficult to do so. In blockchain also, it can be, one can attempt to modify the contents of a block, but then we'll see how actually it deals with that and how it ensures that that is not acceptable. Okay, requiring rework on all subsequent blocks and it's difficult. It's almost impossible. Why? Because of the distributed ledger. Now it has multiple copies with multiple entities because it's a networked manner, peer-to-peer networked, right? Each one having the same copy. Now, if you want to change certain thing, you have to change at every place, which is actually impossible. Okay, or let's say it's extremely difficult. Fine. The transaction is immutable. Okay, so in database terms, blockchains are write and read only. You write once and you can read only. That's it. Like a ledger written in ink, like you have the traditional ledger, it's written in the ink, then you cannot. So any modification you want to do, you don't cut it off there. You just write a new entry with a new timestamp, write a new entry. Fine. So this is example of how a distributed ledger, of a distributed ledger, how it is immutable. Now, for example, you see, you have different transactions gathering. Okay, create the block. Okay, block has the different transactions. So now, for example, somehow a new block is trying to modify here. What will happen? It will be first verified, as I said earlier, because it's in the distributed environment, distributed structure. Okay, so it will be easily detected because now all of the nodes in that distributed environment don't have the same copy. They detect it. Something new is coming. Okay, so there is some modification. So that block actually will be validated. It will not be accepted in that chain. Okay, so that will make this actually invalid. So that's the mechanism how it detects. Okay. Again, what is the possibility? Possibility is only if somehow one is able to change the value of a block across all the nodes within that span of time. Okay, time is also of critical importance. Then it's allowed. But then actually, practically, that is very difficult to do. Okay? As against a centralized system. As against a centralized system. If it's a centralized database, what do you have? You have it at a centralized location, a hub. You have to change only at one place, and many other places it gets reflected there. They have no way of verifying whether this is corrupt or not, or whether there is some modification or not. There is no way of knowing it. So if you want to change it only once at one place, then fine. I mean, it's here, it's more vulnerable, okay, as against the blockchain network distributed ledgers. Now, if you want to change here, you have to change at each and every node. You understand? That's how actually it provides that protection mechanism. Okay, immutability. Fine. Then we talk about encryption. Okay, what is encryption? Okay, there are different these blockchains. Okay, they allow the users also to define their own encryption, but then again, it may not be that easy. Okay, it needs a lot of support, but then it also provides from there, they already provide some standard encryption practices that can be used. Okay, so all blocks are encrypted, fine. So the thing is, when it's encrypted, it's not possible for the, that something we call eavesdroppers. Okay, those who are listening illegitimately to some conversation. Okay, so here the conversation is the transaction. Okay, for example, if you are talking to some friend, someone at your door is eavesdropping and listening to the conversation. Okay, but now if somehow you are talking in a language which is something which is coded language, which no one understands except you and your other party, then it's not, even if they hear it, it's not possible for them to decipher it, understand it. Okay, so that's the encryption. So it provides that encryption. Fine. Some blockchains are public, some are private. So based on this, you have public and you have the different categories of blockchains. Okay, public blockchains are still encrypted but are viewable to the public. Again, example of all of us use we use WhatsApp, or we use, for example, these Telegram or Signal, right, to communicate. Now these are all encrypted. This is end-to-end encryption. Meaning, for example, if you are talking via WhatsApp or even your messages, okay, any data transfer you are doing through WhatsApp or these other applications, these are end-to-end encrypted. Means somehow, if, for example, someone is listening on your network, right, you are connected to a network, you are connected to your internet service through your internet service provider. If somehow someone gets to, there are some devices which trap the communication, but then the WhatsApp communication or Telegram communication, even if they catch something, but they cannot actually understand anything because this is all encrypted. For example, you spoke hello or good morning, my friend. Okay, simple English. But then if someone catches it, he will not be able to actually hear hello, good morning. No, something else, some different thing which is encrypted, okay, which needs a key to decipher, which is not available. So it's end-to-end encryption. Similarly here, it provides the encryption here. Okay, so even if someone is able to get some information, but then it's of no use because it's encrypted. Unless and until they have the key, they will not be able to understand this. Okay, that's how it's. Then okay, you have the public blockchains are still encrypted but are viewable. Let me try to open this one here. You can see some examples. Let me open in the. So this is BlockTrail. Let's try to see the contents of this. Okay, you can see here. So this is actually public. Okay, anyone can. Let me For example, try to open one here with this hash rate here. So you can get the information here for the transactions and the worth, okay, and other things here related to this, okay, which coins are being used. So it is Ethereum, there may be some other Bitcoin or any others, right? So there are different now types of these cryptocurrencies, and then you can see all the transaction history here, okay, what blocks have been there, and you can see these are hashes, okay. You want to see the details of this particular transaction, you can see it. It's publicly available, okay, but then again, you cannot change anything. You cannot change anything here, okay. So these are some of the, this is a public blockchain. Similarly, okay, you have private employee users rights for visibility. So in the private blockchain, only those entities which are involved, they only get to see the transactions and other things, fine. So here, customer writes and views all data. Auditor views all transactions. Okay, so the customer writes and views all data. Auditor only can see, okay. Supplier writes and views partner A's data, supplier B writes and views partner B's data. Others are no other entities allowed to access it, okay, in case of private blockchains, okay. Fine. Now again, for example, let's take example of for example, earlier I talked about that the document verification. For example, your documents need to be verified. In the traditional system, you know how it works. It takes a lot of time. But then if it was something like this, okay, someone wants to see your credentials in, okay, what you have done so far, you have passed the O levels, A levels, and this degree, the authentication of that, they get, okay, you provide them the public hash and then they can view it, okay, verify it here, because it cannot be changed, okay. So this is one of the things. Now what's consensus? So we talked about immutability, okay. So this is now consensus. What does it do? It ensures that the next block in a blockchain is the only and only version of the truth. There are no multiple versions of this block in this chain, okay. Keeps powerful adversaries from derailing the system and successfully forking the chain. As I said earlier, any attempt to add any other block to this is not actually allowed. Many consensus mechanisms, each with pros and cons. Okay, these are the consensus algorithms. We have proof of work, we have proof of lapse in time. We're not going into details of it. These are algorithms which are used in the consensus. Okay, each has their own advantages and disadvantages. Okay, so the two parties, so when they agree, okay, so it's mutually agreeable, and then they employ these mechanisms in their blockchain. Fine. Then next, smart contracts. Smart contracts, as I said earlier, nothing but a computer code, simply like you write your Python program, you write Java program, something, it's a program, nothing else. So it's a computer code which can be executed. There you define terms and other things, okay? It provides business logic layer prior to block submission. Before the block is submitted, it provides the details, okay? It provides the what we say, that the contract defines what should be there before the submission, okay? So this can be written in a programming language, okay? It provides automatic verification, validation, and immutable recording of transactions. So this is all done in the contract. Once it meets all this, then only it allows you, the smart contract, it allows you to submit, and this block can be then added to the blockchain. Okay, now there are different languages that can be used. For example, if you talk about Ethereum, okay, it uses a language Solidity. Okay, Hyperledger is something, it is Linux based, open, this distributed ledger. It uses different languages like Google's Golang, it uses C++, and etc. Okay, in fact, you see, you can write the smart contracts in, JavaScript, you can write in JavaScript as well. Okay, so there are different languages actually that are being used to write the smart contracts. Okay, so what is there? Okay, you have the sending, receiving, you verify the sender, verify the receiver. That's all in the part of the in the smart contract. Okay, defined there. So for example, if you take example of Ethereum stack, Okay, so they also use blockchain. So if you see, so on top of the hardware, you have the network protocols and operating system protocols. So the network protocol, for example, how the communication happens between because when we talk about hardware, what is the hardware involved? Go back to the earlier diagram. We said that the base of it is the internet. Internet is what? It is nothing but it's number of it's network of networks. Actually, you have computers which are connected to each other, they form network. Then you have one network connected to the other network connected, so you have that whole this infrastructure which is created. That's the internet. So it consists of what? Different machines. Machines have operating systems. Okay, so in order for different machines to talk, means that computers to talk, there needs to be protocol. Okay, like in case of web, you have HTTPS protocol. Similarly, in order for the machines to communicate, to share the data, okay, communicate at the network layer, we have something called as, we have like different protocol is nothing but a guideline or set of rules which govern the communication. Simple. Okay, that's the protocol. Fine. So here you have network protocol. I just mentioned here, for example, there is TCP/IP, okay, transmission control protocol or internet protocol, and you have different other protocols. Fine. Similarly, operating system. Now, on top of that is blockchain protocol. So blockchain has its own protocols, which ensures what? It ensures the security. It ensures, like we talked about earlier, the immutability, the contracts, and all other things. They are provided by the blockchain, which allow you to perform the transactions securely. So it has that decentralized system. Okay, so that whole thing that comes under the blockchain protocols. Okay, so this layer implements blockchain functionalities such as transaction to block. You have the consensus algorithms and others. Okay, so this is at the blockchain level. Then you have virtual machine. Okay, smart contract logic, decentralized blockchain applications. Okay, so this is another layer, top layer. Now the thing is, okay, I'll try to go quickly because it's around already 1 hour. So why blockchain? If you see the evolution of computing, where from we came earlier, we had, everything is manual. You go to school registration, you go to the hospital, you go to banking, you want to withdraw the amount, you had to go to the clerk, you had to give your passbook, they will check the entry. So everything was manual. Okay, it was earlier. Then we had with the introduction of mainframe computers, so the things started getting automated. Okay, so mainframe systems held data and computing. So your data is now in centralized systems, and then different type of computations are performed. Okay, still it was not mainstream. Okay, it was limited to some research institutions and some big business houses only. Okay, then you move on personalized computing systems. Okay, you have the especially with the Microsoft's Windows. Okay, now you have computers in easily you can operate. So every house you have the personalized computers. You have the computers, right? So that's the stage here. Then we have centralized distributed systems. Okay, distributed autonomous processes connected by networks and protocols. Like you have the Amazon. You have these are the technology giants, Amazon, Google, right? And all these, they have the centralized distributed systems. Now what it provides, the blockchain, it provides that decentralized thing. Okay, again, especially here, it's not only about data, it's more related to the transactions. Okay, and these are distributed across different nodes. Again, when we talk about nodes, we talk about the hardware, we talk about computers. Okay, fine. And they store these transactions. Fine. So we are moving towards this now, decentralized systems, and blockchain provides you that. Okay. So what it allows is it allows a seamless access to, and it provides a mechanism to perform transactions which are verifiable, okay, which are safe, okay, and which actually important thing is which doesn't need any intermediary. Again, you have to understand, when someone between the transaction there is some intermediary involved, there is the time is involved, means it takes more time than money, it takes commission. Okay, many other such factors are there. Fine. So what blockchain will enable is, okay, so we already discussed about the different hardware levels, the different which enables the blockchain, the different software protocols. So blockchain is meant for trusted peer-to-peer. So this trusted is very important. And it's not about the information exchange, it's about transactions. Okay, trusted peer-to-peer transactions. Okay, you want to perform some kind of transaction with another entity, you don't have to involve someone else. Okay, it is people participant centered, so it's people centric. It is not about programming, so it's not something like you have to all about programming or development. Okay, it's a different mode towards the transactional side. The technology encompasses all business domains, not just fintech. Like one of the important use cases of this is cryptocurrencies, that's a Bitcoin, but then it's not limited to the fintech only, financial technology only. It's as I said earlier, you can use it in any of that. You just name it, governance. You use it in education. You use in the supply chain management. Okay, so it is like the internet, but with a trust layer. So what we want is, like in case of the information, we want to have a verifiable information. We want to have the information which is secure. When you exchange, it should be secured, so it has protocol. Similarly here, the blockchain provides you that. On top of internet, it provides that layer, that trust layer. Okay, it will allow enterprise and people to transact across the geographical borders. Okay, fine. Now where is it now? So we discussed what it is. Okay, or before why it is, then what actually it is. Now where you can see this blockchain. Again, these are the different use cases. You talk about any of these, the use cases of blockchain. You have healthcare, you have insurance, you have Internet of Things. Okay, you can see different applications of the blockchain. Fine. Yeah, this one important. You have this. You have the governance. You have integrity verification. Okay, especially related. For example, if you have some, you're talking about the IP rights and other things, so you can employ this. So anyway, this is already used quite a lot in this area, financial, in terms of the cryptocurrencies. Okay, but then now you can see slowly it's being utilized actually in other areas as well. Okay, fine. So let's see some of the use case. For example, in the healthcare. Okay, in the healthcare industry, you see blockchain is being used. For example, if you see the healthcare industry, its requirements. The requirements are, you go to any hospital or you go to clinic. Okay, first time, okay, of course they ask your IC, so your records are there. So the thing is, these records are okay, so limited to that entity only, maybe a chain of hospitals, chain of clinics, that's it. Then pre-authorizing payments, it needs settling insurance claims, that's what the hospitals and clinics, performing and recording other complex transactions. So these are the requirements of the healthcare. For now, how they are handled. Okay, currently, how these are handled? These are handled. You have the centralized DB. Okay, again, access is limited. For example, sometimes I want to get my health records. Maybe I want to go to some other doctor for some second opinion on some issue, for example. So if I go to the clinic which I was visiting before, it's difficult to again ask them the documents. They are reluctant to provide. Hospitals are reluctant to provide. So the thing is, access is limited here. Okay, although it's your own information, then it's vulnerable to security breach. Okay, like different firms or different, there are different entities which actually benefit from such data. So this is vulnerable. There can be security breach. Okay, because it's stored in the centralized system. Okay, what are the security mechanisms they are employing and other things. Okay, it's actually vulnerable. Okay, it may be breached. Now, what blockchain provides in this healthcare sector? So again, you go back to the blockchain characteristics. Tamper-proof. Okay, that's the immutable. So even if someone accesses it, is able to access it, it's tamper proof. You cannot change the record. Okay. Then reduce time in resolution of insurance claims. Again, because all the entities involved, they have that in the form of what? In the form of distributed ledger, shareable. Okay, they don't have to again ask and then it will come back after some time. No. So the time again, because for the insurance, right, they will check with the healthcare provider regarding the, for example, for a patient, they will check about the disease and then they will approve or disapprove. Okay, so that takes time. But then here, if it's already available with them, it's easy to process the claims. Then complete medical history of patient for use by physicians for precise drug recommendation. Again, the access of the information is it's available there. Okay, again, the entity has to be in the blockchain first. Okay, provided they are in the blockchain, then of course they can easily access it. Fine. Unlike in case of centralized DB, they have to request. Fine. Other use cases, as I said earlier, you have education, you have financial services. Okay, financial services like the cryptocurrencies talk about supply chain management. You talk about shipping industry. You have the huge volumes of these goods traded across different countries, across different continents. Okay, you have different containers moving. So you see this one. So in the supply chain also it's used. Okay, then insurance, government. So all these are the now important to talk about the cryptocurrency here. Okay, because as I said, Bitcoin is quite it's a buzzword, and without Bitcoin, if we are discussing the blockchain, it is actually it may not be complete without we talk about the cryptocurrency. So what is a cryptocurrency now? One is what we have. We have the currency in different. You have cash. You have in the paper form, or you have in the bank. Okay, again, that's digital, but then actually that's backed by something. Okay, so here the cryptocurrency is digital currency based on blockchain. So it uses blockchain technology, secured by cryptographic mechanism. So any exchange, for example, you want to receive some amount, that will be again between peer-to-peer entities only. There is no intermediary involved. Can be used as a form of payment or investment. Many people you see now, using investing in the bitcoins. Okay, examples are Bitcoin, Ethereum, and etc. So there are many others. Okay, so if you talk about the connection between the two, blockchain and Bitcoin. So blockchain is what actually? It's enabling technology. It's enabling technology, and as you see here, it makes use of the blockchain. So what worked for cryptocurrency should work for other business transactions as well. So now, if it can work with a financial transaction, it can work with other transactions as well. So what it uses is mathematical algorithms and other things that we have seen earlier. Fine. So very quickly, what is Bitcoin? Is a peer-to-peer cryptocurrency that does not require a middle entity, such as a bank regulator, okay, to complete a transaction between sender and receiver. It's only between the sender and receiver. That's it. Okay. And the thing is, someone cannot send you the amount if he doesn't have, because this is all verified. You can see it. You can verify it, how much he has. Okay. If someone tries to do a transaction and he doesn't have that amount, okay, it's easily actually verifiable there. Created by secret. Okay, if you just go to the history of the Bitcoin, there is a name called Satoshi Nakamoto. He came up with the first white paper on the blockchain. Okay, in this how we can use this blockchain so he was the first one. It's a secret to name, whether he's a person, he's a group, it's a group, whatever. I mean, it's not known actually. Okay, yeah, it's not known yet who's the person or who's this entity. It runs on the internet to keep track of transactions, and again we have discussed this. It makes use of ledger. Okay, ledger is distributed and is collection of blocks of transactions. Fine. So how do you trust the ledger? The trust model out of this distributed ledger is an important contribution to Bitcoin. So that's the trust factor that is provided by the blockchain technology. Okay, you have these different characteristics. You have the decentralization, you have the immutability, you have the contracts, you have the consensus. Those all protocols, okay, they ensure that extra layer of security, okay, extra layer of trust. So once there is trust, then there are different types of investments, there is transactions and other things, okay. So the distributed ledger and associated concepts are called blockchain. That's fine, okay. Bitcoin technology is the genesis for the blockchain. So nobody knew probably blockchain when the Bitcoin actually came into being. It was first when it came into being in 2008, 2009. Okay, then people came to know, okay, there is something called as blockchain, okay, because it uses the blockchain technology, okay. Currently, if you see, the Bitcoin is one Bitcoin is it equals to how much it is, around 65,000 US dollars. One Bitcoin is worth 65,000 US dollars. I remember quite only a few months ago it was around in 30s or so. So it's almost doubled now. Especially now, if you follow the news, there is in the US they've opened the first US Bitcoin is linked ETF, which can be invested, traded, and other things. So it propelled its shares of this company. Okay, so this is the worth of a Bitcoin. Okay, but then again, there are certain, it's fraught with issues, vulnerability. That, especially when you talk about countries like China recently. Okay, they declared all cryptocurrency transactions illegal. Okay, before, if you see, most of the mining was happening, if I'm not wrong, it's around 70 to 80% was happening in China alone, just a few months back. But then abruptly in September this year, they stopped, and they have brought it almost to nil. There is no mining actually happening. Actually, it's not recorded. No mining happening in China now, which actually before it was 70% of it. 70% of it was coming from China. But then again, as I said, one more aspect of it is the regulators, especially in the financial transactions. Okay, still they have issues with the regulating bodies, like especially Malaysia also, like Bank Negara not allowing them. Many other countries also. Some countries allow, but then again, it's still kind of not recognized. Okay, one important thing being said is that, like in case of the currencies that we use, for example, the fiat currency, the money we have, the paper currency, it's something, for example, if we have $100, it has some worth in terms of there is some guarantee. Okay, there is Central Bank of America probably, which is guaranteeing the worth of it. But then with Bitcoin, it doesn't have any intrinsic value. Okay, where does the value come from for the Bitcoin? That's one kind of one debate or one discussion. Okay, so again, we have to see whether this will be a kind of disruptive technology. It has its own these vulnerabilities. The Bitcoin also. Okay, so as I said, the China has already banned, and let's see. So this is about the blockchain. Okay. So any questions here?
Ya, thank you Dr. Koyum for the presentation. Nah, buat adik-adik yang sekarang punya pertanyaan, bisa langsung tanya tentang tadi, mungkin cukup too much information ya buat kalian sekarang masih kelas 12, kelas 11 atau kelas 10 di SMA. Tapi nggak apa-apa, tanya aja kalau misalnya kalian ada pertanyaan, bisa langsung bertanya sekarang ya.
Yes, Mr. Bobby, may I ask a question?
Yeah,
Yes, please.
Okay, blockchain technology. That was a really interesting concept, yes? The presentation is also really magnificent. But may I ask, what makes blockchain technology special and distinguishable from other technologies out there?
Okay, I just give a specific answer here. Now let's talk about the transactions, especially the financial transactions that are happening now. Okay, I gave the example previously also. Currently, how this all financial transactions are happening is through, there are centralized systems. So this is all actually stored in a centralized databases, and then you have the regulatory bodies involved. Okay, like I give example of the banking transaction. So in Malaysia, you have the Bank Negara, which provides the regulations, rules and regulations for the transactions to happen. it's not only about like at a small scale that we are transferring some amount and transferring some front. At a larger picture also, you have to see the business between the two big entities. Okay, so the thing that there are intermediaries involved, it has a lot of issues. One, the time. Okay, the transaction, it takes time. As I said earlier, if you see the practically, that it has, I think if I'm not wrong, it has the 15-day gap once the from the initiation to the end. It can be reverted in that 15-day period. Even if you see the credit cards also. Then also these intermediaries, they take their own fee. Okay, as against now, if you see and yeah, one more thing is the security also. Okay, now if you see the blockchain, because it's peer-to-peer, there is no other entity involved. I want to transfer something. If I talk about financial transaction, I want to invest somewhere, I want to do some other transaction, fine. So it doesn't involve any intermediary. So that time, one is that it's in earlier case, it used to take a lot of time. Here, that's saved. Also, it provides the mechanism that what we say that verifiability. It provides that trust. That's important thing. Okay, it cannot be. That's why actually, if you see a lot of talk about the Bitcoin or the cryptocurrencies, is that many because many governments are not allowing it because they say like the money launderers, they are using it, terrorists are using it. Why? Because it cannot be tracked. That may be one, you can say, negative or whatever aspect it is. So that's one aspect of it. It's not known because there is no regulator involved.
Yeah.
Okay, so that's one thing.
Yeah. One thing, Dr. Qayyum, I'm afraid if you have classes now,
Yes,
I
around
mean,
12.
around 12.
Next
So,
5 minutes or 10 minutes.
Oke. So buat adik-adik yang ada pertanyaan, mungkin Dr. Qayyum nggak bisa terlalu lama. Mungkin kalau nanti misalnya udah waktunya, mungkin saya bisa bantu jawab saja. Tapi sekarang kalau saat ini ada pertanyaan, silakan tanya langsung.
So if don't have anything, then I may ask your leave. Is it fine?
Ya, oke.
Okay, thank you everyone. Thank you for joining me.
Thank you for your time, Dr. Qayyum.
Okay.
Ya, buat adik-adik yang lain, kalau misalnya ada pertanyaan, saya mungkin bisa bantu jawab, dan mungkin saya bisa elaborate juga tadi yang disampaikan Dr. Qayyum terkait dengan kenapa blockchain teknologi itu lebih bagus digunakan bahkan waktu-waktu ke depannya adalah karena transaksi yang berlangsung dengan blockchain teknologi itu memungkinkan dari end to end. Artinya contohnya kalau saya sekarang punya handphone dan saya pengen jual handphone saya akan taruh di Tokopedia gitu loh. Nah, di Tokopedia nanti Tokopedia bakal promosikan kemana-mana sampai nanti ketemu orang yang berminat gitu loh. Nah, saya misalnya si A yang menjual dan si B yang membeli ini kan transaksinya terjadi, tapi ada intermediaries-nya. Tokopedia inilah yang menjadi intermediaries-nya. Dan di Tokopedia pun juga melibatkan ada bank juga yang terlibat di situ, ada banyak middleman di sana gitu loh. Nah, teknologi blockchain ini memungkinkan transaksi itu hanya terjadi dari A ke B tanpa ada intermediaries ini. Jadi di situ bisa transaksi apapun itu bisa jadi lebih efisien dari segi waktu, biaya, dan banyak hal lainnya, dan lebih secure juga gitu loh.
Baiklah, permisi Mr. Bubi, saya izin bertanya, kira-kira bisa nggak ya?
Ya, boleh, silakan.
Baik. Seperti yang dijelasin sama Mr. Qayyum tadi tentang blockchain, kira-kira ada nggak kekurangan yang didapat dari konsep atau blockchain itu?
Kalau kita melihat point of view-nya adalah saat sekarang ini, tentunya kekurangannya masih sangat banyak ya. Di antaranya regulasi dari pemerintah di setiap negara di seluruh dunia itu masih sangat minim sekali gitu loh, sehingga itu memungkinkan blockchain ini menjadi media di mana orang-orang menjadikannya sebagai media untuk melakukan kejahatan. Contohnya seperti pencucian uang gitu loh. Kenapa bisa menjadi seperti itu? Karena blockchain ini sangat secure dan itu tidak bisa dilacak. Jadi misalnya Pak Rifki nih misalnya melakukan mau transfer uang ke atau transfer sejumlah Bitcoin mungkin ke seseorang gitu loh. Itu nggak akan bisa dilacak gitu loh. Itu anonim, yang pengirimnya anonim, penerimanya juga anonim gitu loh. Nah, yang dimungkinkan oleh blockchain ini adalah transaksinya itu terjadi secara langsung dari end to end gitu. Nah, regulasi dari pemerintah di seluruh dunia sangat minim saat ini karena ini termasuk terbilang baru. Tapi kalau kita melihat antara efisiensi dan keamanannya, ini akan sangat potensial, akan berkembang pesat ke depannya, terutama dari hal-hal kesehatan, pendidikan, militer, dan lain-lain gitu loh. Jadi dan di Indonesia sendiri salah satu bank itu Bank Permata itu sudah mulai menerapkan teknologi blockchain dalam sistemnya mereka. Dan ini adalah bank pionir pertama di Indonesia yang sudah menggunakan blockchain, dan bukan hal yang tidak memungkinkan, akan banyak lagi sistem perbankan ke depannya yang akan mengadaptasi teknologi blockchain ini. Nah, buat adik-adik SMK Telkom saat ini yang mungkin sekarang masih SMA dan mungkin cuma baru ngelihat blockchain sekarang lagi rame diomongin di Twitter atau di Instagram gitu loh, atau di TikTok gitu loh. Harganya naik $65.000 atau satu blockchain sekarang harganya sudah sekitar 900 jutaan gitu loh. Nah, mungkin ke depan 5 tahun lagi ketika kalian kuliah IT dan kalian sudah terjun ke dunia kerja gitu loh, kalian bisa jadi kalian adalah salah satu teknisi atau programmer yang membuat aplikasi berbasis blockchain untuk diterapkan di startup di Indonesia atau financial technology, fintech di Indonesia gitu loh. Itu sangat mungkin karena blockchain teknologi ini relatif baru, dan kalau adik-adik sekarang menerima informasi hari ini, berarti adik-adik nanti akan memakai atau bekerja yang berkaitan dengan blockchain teknologi ini nanti di 5 tahun atau 7 tahun ke depan, di masa depan nantinya gitu.
Baik, terima kasih untuk penjelasannya, Mr. Ruby.
Ya.
Mungkin dari teman-teman yang mengikuti via Zoom atau YouTube ada pertanyaan, bisa langsung disampaikan di kolom chat.
Oke, ini ada pertanyaan dari RPL 5 Loka. Apakah butuh modal yang besar atau hanya skill saja? Oke. Pertama untuk kalau misalnya kalian mau modal besar, saya asumsikan ini tentang berinvestasi di blockchain. Sebetulnya di blockchain itu ada banyak banyak item. Jadi mungkin yang buat kalian yang udah ikutan percakapannya, diskusinya di TikTok atau di sosial media manapun, ada yang bilang NFT, non-fungible token, ada Ethereum, ada Bitcoin. Itu adalah salah satu item di cryptocurrencies yang diperdagangkan gitu loh. Dan kalau misalnya butuh modal besar atau enggak, setahu saya untuk beli blockchain itu mungkin sangat mahal sekali ya. Enggak semua orang punya duit 900 juta saat ini. Tapi blockchain itu bisa di fraction. Jadi jatuhnya kalau misalnya kamu cuma punya duit 100.000 gitu loh. Nah, kamu tetap bisa beli blockchain. Artinya kamu nggak bisa beli satu Bitcoin gitu loh. Sorry, bukan beli blockchain, beli Bitcoin. Tapi nanti yang terbeli itu adalah 0,00000 berapa gitu. 0,0000391 berapa gitu loh. Jadi fraction, pecahan kecilnya. Nah, jadi buat orang-orang yang saat ini pengen mungkin tertarik untuk berinvestasi di Bitcoin atau di cryptocurrencies lainnya, itu mereka sebetulnya nggak butuh modal besar, cuman karena berinvestasi di cryptocurrencies ini adalah resikonya sangat besar, tapi itu juga menjanjikan keuntungan yang besar. Cuman kalian jangan coba-coba untuk bertransaksi di sana kalau tidak punya knowledge sama sekali. Pengetahuan di balik itu sangat penting gitu loh. Jadi jangan jadi istilahnya kalau sekarang dibilangnya FOMO kan, jangan ikut-ikutan, tapi kalian mesti betul-betul belajar apa itu Bitcoin, Ethereum itu apa, ekosistemnya seperti apa. Nah, kalau kalian sudah yakin kalian punya knowledge yang cukup tentang blockchain teknologi, nggak apa-apa, kalian bisa berspekulasi, berinvestasi di sana gitu. Ini dari Zulfa, buat help ini bisa langsung coba magang kalau mau coba-coba. Magang di help itu untuk siswa S1. Jadi kalau misalnya kamu kuliah di Help University, kamu itu otomatis memang wajib magang sih, karena magang itu adalah salah satu persyaratan untuk lulus kuliah. Cuman nanti Zulfa bisa consider mau yang magangnya 1 semester 4 bulan atau 1 tahun gitu. Kalau mau magang yang 1 tahun berarti ambil program yang work based learning-nya, di mana itu mesti udah di-define dari awal gitu loh. Jadi misalnya daftar kuliah tapi langsung ambil program yang work based learning. Nah, di situ nanti akan dipersiapkan siswanya agar bisa memenuhi persyaratan untuk bisa magang. Nah, untuk magang ini ke depannya pun juga nanti kamu juga bisa pilih di perusahaan apapun gitu loh. Nggak terbatas hanya di perusahaan IT. Di semua perusahaan, semua industri di seluruh dunia itu mereka punya departemen IT. Nah, nanti kalian bisa magang di departemen IT-nya, mungkin akan handle tentang komputer network di sana atau komputer database-nya seperti itu.
Thank you for explaining, Mr. Bobby.
Yes.
There seems to be another question from Loka again.
Ya, apa saja harus dipersiapkan sebelum memulai magang? Sebetulnya yang dipersiapkan sebelum memulai magang adalah kurang lebih mungkin nilai itu kan secara akademik ya, karena itu juga akan diperhatikan oleh perusahaan, company atau employer-nya. Dan yang kedua adalah ya mental aja sih, karena kan begitu kalian terjun memulai magang, itu kalian kan jatuhnya kalian akan turun ke dunia, ke the real world gitu loh. Kalian akan engage dengan dunia nyata, di mana ya kalau kamu kerjanya jelek ya kamu nggak dipakai, kamu kerjanya bagus kamu akan dipakai terus-terusan gitu loh. Kamu akan mendapat kompensasi untuk itu. Dan di Help University untuk magang yang 1 tahun ini, itu siswanya itu bisa dapat allowance itu sampai 3.500 ringgit per bulan atau sekitar 11-12 jutaan per bulan. Dan kalau disetahunkan itu sudah lebih dari setengah dari biaya kuliah selama 3 tahun di Malaysia.
Oh, wow, Mr. Bobby, that's very interesting.
Yes.
Are there any more questions from maybe the YouTube chat or Zoom chat? If there are no more questions, is there anything you would like to say before closing this event, Mr. Bobby?
Ya, satu hal yang mungkin saya bisa sampaikan adalah buat adik-adik semuanya bagus sekali kalian sekarang itu adalah faktanya kalian sekarang adalah siswa di SMK Telkom Purwakarta, karena teknologi informasi ke depannya itu adalah satu-satunya teknologi yang akan survive sampai ke depannya, dan bahkan teknologi informasi itu akan banyak menggantikan banyak pekerjaan-pekerjaan yang ada saat sekarang ini. Jadi semoga kalian tetap bisa konsisten. Kalian nggak untuk berkarir atau berprofesi di bidang IT nggak harus bisa programming gitu loh. Kalian cuma butuh punya ide, dan ide kalian itu bisa menjawab semua kebutuhan yang ada di masyarakat. Itu udah cukup sederhana, sepertinya kayak Gojek sekarang gitu loh. Sederhananya itu mereka cuma membantu orang yang mencari Gojek tapi nggak mau ke pangkalan ojek. Sesederhana itu aja gitu loh. Dan nanti kalian bisa bentuk tim, kembangkan itu semua gitu loh. Dan ya kalian keep open minded, dan di Hub University kita punya program IT. Untuk S1-nya itu 3 tahun, dan kita punya program beasiswa potongan biaya kuliah untuk siswa-siswa berprestasi. Nanti bisa kalau misalnya tertarik, nanti bisa disampaikan ke gurunya, nanti kita bisa bikin separate session dari sini. And I think that would be all from me.
Oke, terima kasih Mr. Bubi atas masukan dan sarannya. Mungkin bisa langsung di close aja nggak apa-apa?
Okay, thank you, Mr. Bobby, for explaining. And wow, look at the time now. It's 11:06. Time flies so fast. This month's
Yeah.
Living and Playing events have come to an end. We've learned so much in the past events. Am I right, Rifki?
Ya, betul. Betul sekali Kak Jordan. Nggak kerasa kita udah di penghujung acara di kegiatan Living and Playing bulan Oktober ini. Banyak informasi yang kita dapat, mulai dari narasumber, moderator yang keren-keren ya dari Malaysia, bahkan menyempatkan waktu untuk berpartisipasi dalam kegiatan ini.
Yep.
Iya. Oh ya, sebelumnya saya mau menyampaikan terima kasih kepada Pak Jordan dan Pak Rifki, dan juga Pak Andang dan Pak Wiwit, serta Bu Ruli yang sudah memungkinkan hal ini terjadi. Terima kasih sama banyak.
Yes, you're welcome, and thank you as well, Mr. Bobby.
Yeah.
And we apologize if there were any mistakes in bringing out today's event.
Thank you so much.
I'm Jordan, and this is my partner, Rifki. And thank you for watching this month's last Living and Playing event. We hope to see all of you again next month.
Thank you.
Putih-putih bunga melati, harum mewangi di pagi hari. MC kami cukup di sini, jika rindu harap hubungi. Billahi taufik wal hidayah.
Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih.
Waalaikumsalam warahmatullahi wabarakatuh.